welcome to Maths Guru channel. How are you all? I hope you are all fine. In this video, I am going to explain 10th class Maths State Syllabus Chapter 2 Sets. Name of the chapter is Sets. Already introduction over and exercise 2.1 also over. And in this, I am going to explain types of sets. The concept is types of sets. What are the types of sets and what are the examples for that? Let me explain. Okay. First, what are the types? Empty set. First type is empty set or null set, or void set. What other name also there, that is void set. So these are the names of the null set, empty set. Okay, empty set, empty, within the name only there. There are no elements in the set, that is empty. Okay, so when I am explaining this definition, I will explain. Let me write the just name of the types only. Empty set, null set, void set. Next is finite set, finite set, infinite set, subset. These are the few types of sets are there. One more set, singleton set also there. Singleton set. So these are the sets, types of sets. Now let me explain one by one. Okay. Now first one is null set, empty set or void set, or we can call it as void set. Okay. So what is the definition of empty set, null set, void set? Empty. So here definition will give a set which contains no elements. Empty meaning is nothing. Yes or no? So a set contains no elements, that is called empty set. A set contains no elements. No elements. That is called empty set. Okay. Empty set is denoted by letter pi or this one. Okay. Empty set is denoted by letter pi or empty brackets, flower brackets. Is there any elements in this? There are no elements. That's why this is called empty set representing. Okay. Here example, one live example. One example for this empty set. Suppose a set contains prime numbers which are greater than 2. A set of numbers which are prime numbers. A set of numbers which are greater than 2. See, prime numbers what we have? 2, 3, 5, 7, 11. These all are prime numbers. Yes or no? So what I am saying here, a set which contains prime numbers greater than 2. Prime numbers, even prime numbers greater than 2. Okay. A set contains even prime numbers which are greater than 2. If greater than 2 means these are only prime numbers. Is there any even prime? No. There are no even primes. Yes or no? So here we can take it as empty set, that is, okay, a set contains even primes which are greater than 2. A set contains even primes which are greater than 2. Even primes greater than 2 means from this 3, 5, 7, 11, these are the prime numbers, but there are no even primes. That is called empty set or null set. Understand? Next is singleton set. I am going to explain after this. Let me erase. Once take the screenshot. Okay. Here I will explain singleton set. In order I will explain. Let me explain. Okay. Now singleton set. A set which contains only one element. In the name only there. Singleton set. Singleton set. Okay. A set which contains only one element. A set contains only one element. A set contains only one element. That is called singleton set. Single means one. Should remember. Okay. Now here example for this. Just a set contains even primes. A set contains even primes. A set contains even primes. How many even primes? Only one even prime. Yes or no? Suppose one set A I am taking as 5. How many number of elements are there? Only one element. So this is called a singleton set. Here the set which is having only even primes. How many even primes we have? Only one even prime. So that is a set. So these type of sets we can call singleton sets. Means that contains only one element. Okay. Now one more example. See, this is also singleton set example. Why? Because this set contains only one element, that is 0. This set contains only one element, that is 0. So that is called a example of singleton set. Now is it clear? I hope. In empty set, singleton set, both are over. Next I am going to explain finite set. Third one. Once take the screenshot. Next is finite set. Okay. What is finite set? Finite set. What is the definition of finite set? Within the name only there. Finite means we can able to count. That elements we can able to count. A set which contains finite number of elements. A set contains finite number of elements. Finite number of elements. That is called finite set. Example for this finite set, let us take one set. I am taking 1, 2, 3, 4, 5. A set contains these many elements. How many elements? 5 elements. How you know? We are able to count these elements in the set A. 1, 2, 3, 4, 5. We can able to count. So a set which contains finite number of elements, we can able to count. That set we can call finite set. Example one more. Suppose one set I am taking S. Okay. Which contains the factors of 2. Factors of 2. These are factors of 2. What are the factors of 2? 1 and 2 only, na? So factors of 2, 1 and 2. So how many factors are there for 2? 2 factors. What are those? 1, 2. We can able to count the elements which are there in the set S. Yes or no? So this set S is called finite set. Why? Why? Because we are able to count the elements in the particular set. Okay, I hope you understand. Next to infinite set. Infinite set. We can take one more example for this finite set. Suppose one set B I am taking Sumalata. Okay. Here one set contains the name which are there alphabets in that name, that is Sumalata. So in this name some number of elements are there. Can we able to count? Yes, we can able to count those alphabets which contains in that name. Yes or no? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 alphabets are there in the name. Yes or no? So that is also one of the example of the finite set, right? Now coming to the infinite set, within the name only there. Uncountable, we cannot able to count. Okay, the elements we cannot able to count. A set contains infinite number of elements. Infinite number of elements. Example, a set contains multiples of 3. A set which contains multiples of 3. Why I am taking this example? Why? Because any number, every number having how many number of multiples? Infinite many number of multiples. So can we count those multiples? No, we cannot able to count those multiples. So that is called example of the infinite set. Suppose that one set is having multiples of any number. Just example I am taking multiples of 3. Multiples of 3. Can we count multiples of 3? No, we cannot count. Multiples are infinite for any number, right? So we can consider that is one of the example of the infinite set. Okay, I hope understand. So here any one example you can take which we are not able to count. One more example. Natural numbers set. Natural number set. Yes or no? How many we have natural numbers? Infinite many we have natural numbers. Can we count those natural numbers? No, we cannot able to count. Natural numbers are infinite. So this one set which contains natural numbers 1, 2, 3 up to so on. Up to so on means infinite. So that is also one of the example of the infinite set. Next, once take the screenshot. I hope you understand. One more is subset. What is the definition of subset? Subset. Now, definition is every element in one set which contains the elements in the another set. Let us just take one example for this. Example. Suppose I am having one set 1, 2, 3. One more set I am having 1, 2, 3, 4, 5. See here, every element in A also contain elements in B. Yes or no? Every element of A which contains the same elements in the B. 1, 2, 3, 1, 2, 3. Means this every element of A contains the element of B. So here in this case we can call A is a subset of B. A is a subset of B. So we can represent as A is subset of B. The symbol we can call it as subset. Okay, subset. So here we can write the definition. every element of A, every element of A contains, every element of A contains elements in B. Every element of A is elements of B set. Every element of A set is elements of B set. So here we can call A is a subset of B. Yes or no? One more, any example like that we can take it. Suppose I am having one set P, one set Q. Derivate any example we can. Okay. Here one example I am taking Lata. Here one more set I have Sumalata. Okay. Here check it once. Every alphabet of P is also there in the set Q. Yes or no? See, Lata, all the alphabets are there in the set Q. Okay, so every alphabet in P is also there in the set Q. So this type of sets we can call, P is a subset of Q. P is a subset of Q. Okay. So why? Because every alphabet is there in the set Q. Okay. This is about the subset. These are the types of sets. Once recall, empty set. Empty set we can call it as null set or void set. One more, second one is singleton set. Third one is finite set. Okay, fourth one is infinite set. Fifth one is subset. Okay, these only the types of sets according to your syllabus. Okay, I hope you understand. Thank you. For more videos, subscribe my channel, support me. Have a nice day. Bye.